All right, I'd like to get started, please. Okay. Okay. Kylie. Subir. Okay, I want to get started. We're going to start out with. Okay, going to start out with synthetic division. Okay. A linear factor like this. X plus a is called a linear factor because x is to the power of 1. Okay, it's a linear term. Okay. So we cannot do synthetic division, for example, to divide a polynomial by, say, x squared plus 1x plus 2. Okay, cannot use that to divide a polynomial, okay, using synthetic division. And one of the important things that we are doing in this whole chapter is finding zeros of a polynomial. Okay, that's the major goal in this, pretty much this entire chapter. Okay. And so we're going to learn several different tricks of how to find zeros of a polynomial. And in order to be able to do that, we've got to know how to do synthetic division. Okay, so here's an example of how we do synthetic division. Okay. So the polynomial that you're trying to divide is x to the 4th minus 10x squared minus 2x plus 4. And I want to divide by x plus 3, okay? So again, we are trying to do synthetic division in order to divide a polynomial by a linear factor. Okay, can you guys shut up there, please? Okay, everybody got this down? Okay, so a couple of things to notice, okay? So if you have an x plus 3, then this guy becomes a minus 3. In other words, it will be the opposite sign of whatever this term is. So if it was x minus 3, then it'll become, this term would become plus 3, okay? So the way you do this is you bring down the coefficients. Okay, you bring down the coefficients. So you can see that x cubed is missing, okay? So since it's missing, you're going to put a 0 there. Then you've got the x squared term, its coefficient, x term, its coefficient, and the constant term. Okay? And to do synthetic division, all you do is write down the coefficients, put the minus 3 here, which again is the opposite of whatever that term is. Okay? You bring the 1 down, you times the 1 and a negative 3 to get negative 3. You add 0 and negative 3, you get negative 3. You times negative 3 and negative 3, and you get 9. You add negative 10 and 9, you get negative 1. Udara, the next time you want to do this, I'd really appreciate it if you do it instead of bullshitting when you come in. Do that first. Okay, get your job done that needs to be done instead of BSing. Times negative 3 by negative 1, and you get 3. Get 1 when you add negative 2 and 3. You times negative 3 and 1, and you get negative 3, and you add that, and you get a 1. So this is your remainder. That's your remainder. So from the polynomial long division algorithm that we learned last week, what you need to do is you need to write this as x squared, x to the 4th minus 10x squared minus 2x plus 4 is equal to x plus 3, your divisor, okay, times your quotient. Now your quotient is, since this is x to the 4th, this guy is going to be 1 degree less. So it's going to be x cubed minus 3x squared minus x plus 1. And then your remainder is going to be plus 1 over x plus 3. Actually, that's not true. Your remainder is just 1. Right? Remember, there are two forms of writing the division algorithm, okay? There's one where the divisor is put on the right-hand side and one where the divisor is put on the left-hand side, okay? So you guys better know both of them. All right, everybody got synthetic div? Yeah. Yeah, remember there are two ways of writing the division algorithm. This is one of them, okay? The other one is x to the fourth minus 10x squared minus 2x plus 4 divided by x plus 3 is equal to your quotient plus your remainder. So there are two different forms of writing it. Okay? Is everybody all right on this? Yeah. If I tell you, then you do what I tell you. If I don't tell you, either. Okay? It's all right? Everybody okay on this? All right. I think the next one's an example for you guys to practice, I believe. Yes. Right, so now we come to the remainder theorem, okay? And why don't you copy that down and then I'll explain what it means, okay? Some of you might know that this is also called the Chinese remainder theorem. So if you ever Google any math stuff, okay, sometimes it'll show up as the Chinese remainder theorem because it's attributed to Chinese for doing it a long time ago. I forget what, 700 BC. So let me explain what the remainder theorem really is saying, okay? So this is what the remainder theorem is saying, that if you take f of x, right, and you divide it by x minus k. So x minus k is your dividend, divisor, remainder, quotient. Which one? The dividend. So what you will get is you'll get some quotient times your dividend plus your remainder, right? Plus your remainder. So if you take a look at this, notice that these are all functions of x, okay? So if I put x is equal to k, which means that wherever I see x, I will put k. Right? What happens to this here? It goes to 0. Disappears. So isn't fx or fk equals rk? Okay, in other words, the remainder, okay, which is what this is f of k. Does everybody understand what f of k means? Yes? Anybody have questions on that? Who'd that be? Ray? Ask Priscilla. She knows everything. She's a stud. What's f of k? Not only that, but if it wasn't in the context of remainder, what would f of k mean? By doing what? Exactly. Is everybody there? Zara? What? The scratch is confusing? You want me to kind of erase it so that it's not confusing then? Isn't this should have been k? This was k, right here. Isn't k minus k 0? Well, if you times anything by 0, oh my God. Okay. All right. You times anything by 0, it's 0. So hey, it's not worth keeping it there, is it? Okay. All right. So that's what the remainder theorem is saying, and this is actually the conclusion that really comes from the remainder theorem. Okay. So supposing I wanted to do f of minus 2. Okay. I want to do f of minus 2. What is the most straightforward way of doing it? Algebra 0. Sorry? Okay, do it. Do it. Without a calculator. Yes, without a calculator. I'll race you, Zara. Come on. Come on, Indian against Indian. I have slowed down so much, man. I could do this in like 30 nanoseconds. I've become an old man now, seriously. So that's minus 98, 98 and 32 is 10, 3, 1. Watch me kind of mess this up, okay? Did I already mess it up? Sorry? It is 96. But I wrote 96.
You did the math on when 98 like under the 32, you put 98.
No, that's 96 minus 2. Oh. Negative 96 minus 2 is negative 98? Yes. So negative 98 plus 32 is negative 130. Anyway, I'm not trying to teach you arithmetic here, okay? You want to go back to Gomes if you need to do that, okay? So this was the old-fashioned way of doing it. Okay, that's the old-fashioned. Did I smoke on this one? Did I get this right? Well, let's see what happens, okay? So that's one way of doing it. But today we learned a new way, okay? Shh, 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 shh. Oh my God. Just don't shut up. All right? So what you need to do is do synthetic division. So you're going to write 3, a negative 2, and then what? And then what? 0, then a 2, a negative 4, a negative 2. And what are you going to put here? You're dividing by x plus 2, so you're going to put a negative 2 here. Is everybody with me on that? Okay, you put whatever this number is. You don't reverse this. You reverse it only when it's something like that, you would reverse it. Okay? So bring this down, you get a 3, a minus 6, a minus 8, a 16, a negative 32, a negative 30, and that'd be 60, and that'd be a negative positive 56, negative 112. I did F up. This should have been 114. Okay, Zara, you lie. You lie, Zara. You said I did it right, sorry?
No, I didn't answer.
Negative 114? Yeah, but I asked you 3 times, did I F up? Did I F up? And Zara said, no, you didn't. Yes to both. So I'm smoking and I get it right, so smoking is good for you then? Isn't that a logical conclusion you make? Oh my God. Alright, is everybody okay on this? How to do SynDiv and get the function evaluation? Is everybody okay on this stuff? Kylie, you're not here today. I know you're here physically. Are you here mentally? Okay. Okay, so now we have another theorem now, okay? We have another theorem now. Okay, shh. Okay, so what we have now is called a factor theorem. So remember that fk was supposed to be equal to your remainder, right? This was your remainder, right? From the remainder theorem. So if the remainder is 0, then this must be a factor of the polynomial that you start out with. Just like if you divide 6 by 2, what's your remainder? 0. So 2 is a factor of 6, right? Does everyone understand what a factor means? It means that if you divide something into the starting function, if the remainder is 0, then what you're dividing by, i.e. your divisor, is a factor. Okay, it's a factor. So right here they give you that x minus 2 is a factor. They tell you this is a factor. Which means that if you divide this polynomial by x minus 2, okay, then your remainder should be 0. Right, Thomas? Are you here? Are you thinking about how to jump the juniors? Yeah, I mean, you guys are going crazy right this week. This is crazy week.